that be? So you just take f of x, put it over g of x, and that's your function. But since we have errors with division, we have to tell the reader, hey, this is your function, but you can't use the value what in this equation. So we have to decide what value can we put in for x so that we'll get 0 in the denominator because we don't want it. So we have to tell the reader, beware of that number. So we have to decide when this is going to equal 0. When is that going to happen? It's unfactorable, but it's a quadratic. So if you put in the quadratic formula, opposite of b plus or minus the square root of b squared minus 4ac all over 2a, you will get 4 plus or minus 2 root 3. Okay, so let's show the here to there progression. So it's going to be 8 plus or minus, you're going to get under the square root. 4 times 4 is 16. So 64 minus, it's going to be square root of 48 all over 2. So this is going to be 8 plus or minus, well, the square root of 48, it's going to be 6 times 8. So that's 4 2's and a 3. Take 2 of the 2's out, so it's 4 root 3. But I have this 2 on the bottom, so 2 will stay under the bottom here and here. 8 divided by 2 is 4. 4 divided by 2 is 2. So this is your answer. Here is your f over g of x. And by the way, x cannot equal 4 plus or minus 2 root 3. Because if I plug this in, I'll get 0. We don't want that. All right, the next one is find f of g of x and g of f of x. So this one's saying put g of x into your f of x function. What do you get? So I know my f of x function is x minus 4. I know I'm going to replace x with something, so I left some room. Well, I'm replacing x with an entire function, x squared minus 10. When I simplify that, I'm going to get x squared minus 14. That's my function. Then I also have to find g, it's another way to write it, of f of x. So my g function, well, x has to go through f. When you put x inside f, you get x minus 4. Then you have to take that function and put it into x here. So g is my outermost function I have to work with. So I write it first. X squared minus 10. I'm replacing x with x minus 4. I'm squaring this whole quantity. So it's going to be x squared minus 8x plus 16 minus 10. X squared minus 8x plus 6. You really got to practice this one. It comes back and never goes away. Composition of functions. So make sure you've mastered this, especially for pre-calc. Now, the question asks, if they exist, which they do, state the domain and range for each composition of functions. Well, I get a quadratic. We know quadratics are polynomials, and polynomials have domains of all real numbers. Or think about it logically. What numbers can I square? Positives? Yes. Can I square negatives? Yes. Can I square 0? Yeah, I'm not going to have any issues. But what comes out? So if I graph this function, I know, just from transformations, because we're so smart, that this is x squared, and then it's going down 14. So I know it's going to be down here at negative 14, and it's going to go up. So my domain, all real numbers, my range, y is greater than or equal to negative 14. Here, though, it's not as cute as this one. It's not just dropping down 14. There's an 8x here and a 6. I really don't feel like completing the square to figure out where it starts or stops. So I'm going to just graph it. I'm going to put in x squared minus 8x plus 6. I'm going to hit graph. Okay, so it's down there. So I'm going to go to my window, and I need more negatives. So let's try negative 12. So it looks like at 1, 2, 3, 4, when x is 4, what is our y? Let's go to second table. When x is 4, y is negative 10. All right, so our lowest number is negative 10. Could you have just done trace? You could have done second, trace. Oops, I'm sorry, or just trace. Just traced it. What is that number about? This is not the most accurate way, but you're like, oh, okay, it's about negative 10. All right, so that's how you do that one. And then this one asks, the number of women and men age 16 and over employed each year in the United States can be modeled by the following equation, where x is the number of years since 1994 and y is the number of people in thousands. So if y is people, this is people as in women, and that's since 1994. Okay, years since 1994. So how many years since 1994, if you can figure it out? You'd put that number in here, and that's supposedly the number of employed women. I don't know if this is even true or not, but I'm assuming there's some truth to it. And how did they figure out these equations? Just like we did bungee jump Barbie. Probably not that simple, but these equations come from data. Okay, and then in men, this is the number of men employed, and then this is the years since 1994. So you'd put the year since 1994 in here, and that's supposedly the amount of men employed in the United States. I mean, try it with 2020, and then, well, I guess don't do it right now with how many people are employed or not. But try like looking at the year 2019, seeing how many people were employed. Does this equation actually work? All right, it says write a function that models the total number of men and women employed in the United States. So total is adding these two together. And when you add these two together, you put the x's together and you should get 2085.6x plus 123,060 people. So that equation represents all the people, supposedly. So you could use this for just the total population, and that would be men and women. B is the function represents, if f is the function that represents men and g is the function that represents women, what does f minus g represent? Now, I'm not asking you to literally find it. It's asking what does it represent? And I would just say it is the difference between employed men and women in the good old US of A. Okay, just be kind of thorough with it. All right, so that was the first section, just like operations with functions. The next one is from 6 operations on functions. So this is saying, hey, if this is our discrete function, you're telling me 4 goes to 3, negative 4 goes to 4, negative 3 goes to 5, and 5 goes to 2. That is a function. 3 goes to 4. If you see 3 again and it doesn't go to 4, then it's not a function. So we're good, we're good, we're good, we're good. It says, is the inverse a function? Yeah, we just said that. What if they are both functions? We said that is called a 1-to-1 function. You don't have to know that, but you're going to hear that all the time. I remember being in calculus and just hearing that all the time. And I'm like, what are they talking about? That's what they're talking about. All right. Then we graphed functions and their inverse. And we noticed that they were reflections of one another. So if my slope is 4, it means I multiply by 4. The inverse of that, and this is how we notate it, the opposite of multiplying by 4 is dividing by 4. So these need to be reflections of each other. And we just begin with B and we move with them. You don't have to write the plus 0, but I'm showing you I begin with 0 and I'm going to go up 4, 1, 2, 3, 4, over 1. Or down, 1, 2, 3, 4, left 1. Okay, and then so this is, you want to make it as pretty as possible. I'm doing this one-handed. And then this one, you'd start at 0, go up 1, 1, 2, 3, 4. Or down 1, 1, 2, 3, 4. And notice how they are reflections on the y equals x axis. All right, here is a formula for, okay, so this is converting Celsius to Fahrenheit. So if it's like 30 degrees out Celsius, you put 30 in for x and boom, Fahrenheit comes out. Okay, So when we say the temperature now, it's always in Fahrenheit. Everyone else uses Celsius. And when I say everyone else, like other countries, they want you to find the inverse and then show that they're inverses. So what we do is say, all right, I can do this logically. I could say, okay, I added 32 first, so I'm going to subtract 32, or I added it last, so I'm going to subtract it first. I multiplied by 9/5 first, so I'm going to multiply by 5/9 last. But if logic's too hard for you, just switch, oh, that sounded awful. Just switch X and Y and solve for Y. So subtract 32, because really, you're just undoing. You're working backwards, and then multiply by 5/9. When you multiply by 5/9, multiply this entire quantity. And we have to say Y inverse. So that is your function. Reminder, you don't have to hand these quizzes in. These are more like, hey, when you finish doing the notes on your own, try one of these homework quizzes. And if you're okay with it, then move on and do the homework, what you think you need to do. It's more of a checking for understanding before you move on. And then it says prove that they're inverses. Well, the thought is if I put this function inside of this function, they're gonna undo each other. So if I take X, do a bunch of stuff to it, then undo a bunch of stuff to it, I should end up with X. That's proving that they undid each other. If you just say, well, this is how you get the inverse, that's not proving it's an inverse. So you're going to take this function and put it in here. So that means you're going to take f of x and put it into the inverse of x. So you're going to get 5/9 times 9/5 x plus 32 minus 32. What do you get? Well, that's just going to cancel out inside. And that's just going to be x. So it checked out. But you can't just do it one way. Maybe it's a fluke, so do it the other way. So we have a function 9/5 x plus 32. Oops. Put the other function in. Let's see what happens. Well, these are going to multiply to get 1. So you're left with x minus 32. Oh, sugar. I'm holding the camera. All right, these two are going to cancel, and you're just going to get x. So that's proving they're inverses. If it says show, that means prove, and you have to do that. And then what does this purpose serve? If this was to get from Celsius to Fahrenheit, then this one was to get to Celsius from Fahrenheit. So F inverse X finds the Celsius temp from Fahrenheit. Okay, so that's the second one. Let's hurry up and do, you know what, no, I'm just gonna make a video of these two. I will make a video of the next two separately. If you have questions on these, feel free to email me. Like I said, you do not have to hand these in, but they're checking for understanding.